vi go?
Du klar, Benjamin. Vær så god.
Ok, takk for det. Ja, jeg kan begynne med en introduksjon. Mitt navn Benjamin Sebastian. Jeg jobber i Data Equipment og har fokus på sky og skysikkerhet. Jeg har gjort det i et par år nå, og trives veldig godt med det. Og med meg har jeg Dima Reshytnik. Dima, kan ikke du si noen ord om deg selv før vi starter?
Ja, det greit. Så Dima Reshytnik, og jeg jobber i Palo Alto Networks. Jeg er lead for cloud sikkerhet ingeniører i Norden, også i Tyskland og Polen.
Ja, supert. I dag skal vi snakke litt om applikasjonssikkerhet. Og ta en liten reise da, tilbake til 10-20 år tilbake med hvordan vi utvikler applikasjoner. Og så litt på spørsmålet om hvorfor sikkerhet så mye viktigere nå enn det noen gang har vært. Og så skal Dima ta en demonstrasjon kjøre en demonstrasjon hvor man viser hvor enkelt det å gjøre miskonfigurasjoner, og i kombinasjon med sårbarheter, hvilke konsekvenser det kan ha. Så kan vi starte med det man begynte med tidligere, da. Det var fossefallmetoden, som en metode hvor man på en måte har, altså hele prosjektet planlagt på forhånd, hvor man legger opp løpet i ulike faser, og så beveger man seg sekvensielt da, fra fase til fase, som et fossefall. Og neste fase kan ikke påbegynnes før den forrige ferdigstilt, og det gjør at ting blir litt rigid, og det vanskeligere å gjøre endringer underveis, uten å måtte endre på disse planene, disse omfattende og detaljerte planene på forhånd. Og det passer best i prosjekter hvor kravene godt kjent fra før, og det lite sannsynlig at det kommer nye ønsker eller krav senere. Den arkitekturen som ofte blir brukt i fossefallmetoden, det monolittiske applikasjoner. Og disse på en måte en pakke, eller en kodebase, som gjør at det veldig enkelt med for eksempel å deployere og utvikle koden og teste koden, men gir deg lite fleksibilitet hvis du har et større prosjekt. Og disse ble ofte deployert på fysiske servere. Og så fant man ut med oppblomstringen av virtualisering at dette kanskje ikke de beste måtene å drive applikasjonsutvikling på. Så da begynte man å tenke agilt eller smidighet som nøkkelordet her. For det man ønsker å gjøre å komme ut i markedet på kjappest mulig måte med best mulig kvalitet og sømløst. Og agilmetoden da, det en metode hvor man deler opp i miniprosjekter, såkalte sprinter. Det en iterativ approach, som gjør at vi på en måte, med alle kravene, planene og resultatene vi har, blir da kontinuerlig evaluert, og har man nye ønsker eller krav, så tilpasser man bare de neste sprintene i henhold til det. Og da har man en naturlig mekanisme for å respondere mye raskere for endringer. Og den arkitekturen man bruker der, det såkalt n-tier eller multi-tier, hvor man distribuerer applikasjonen i litt flere deler. Typisk frontend, backend og database da. Her distribuerer man da disse applikasjonene i virtuelle servere. Og så kom det sky da, og alle mulighetene man fikk der. Brukerne konsumerte applikasjoner på en helt annen måte, og stilte mye større krav, og konkurransen ble også større. Så man på, hvorfor funker ikke, eller hva det man kan gjøre annerledes for å endre eller for å forbedre denne måten å jobbe på? Og da kommer jo DevOps på banen, som egentlig gjør det samme, mer eller mindre. Det en avart av agilmetoden. Og det man ønsker å oppnå her, det jo det samme. Man ønsker å jobbe smidig, men det man så, det var at man var ofte delt inn i siloer. Man har utviklerne på den ene siden, og så har man IT-drift på den andre. Og så har man også sikkerhet da litt på siden her. Så det man ønsker å gjøre er å bryte ned siloene, slik at man kan jobbe og samhandle på en mye bedre måte. Da blir også resultatet bedre. Så det man ønsker å gjøre er også å automatisere disse workflowene, som ofte assosieres med en CI/CD-pipeline, som er kontinuerlig integrasjon, kontinuerlig utvikling og deployment. Og med oppblomstringen av containere og serverless og de cloud native måtene å håndtere ting på, så snakker man om mikrotjenester. Så man fant ut at, eller det var vel Netflix som var tidligst ute, så vidt jeg vet, med å bygge mikrotjenester før det var et begrep, og som har drevet utviklingen videre. Så man fant ut at så hvis man distribuerer applikasjonene i små biter, så har man større fleksibilitet. Og dette gjør at med containere så blir jo det veldig, veldig smidig, for da har man hver eneste lille funksjon kan være en del av det distribuerte systemet, som kommuniserer sammen, typisk via API-er. Skal vi se. Og her kan man se en monolitisk applikasjon, som typisk er hvor alt av applikasjonslogikk kjører på samme server, og hvor perimeteren er veldefinert. Så hvis man setter en brammer foran, så har man kontroll på trafikkflyten inn og ut av systemet. Det er ikke det samme for cloud native. Det jeg snakket om med mikrotjenester og DevOps, det kaller man også cloud native applikasjoner. Det betyr ikke nødvendigvis at det må deployeres i sky. Man kan også ha privat og public sky, eller begge deler. Så her i et cloud native miljø så er ting veldig spredt, og du kan bruke både flere skytjenester, skyplattformer, og det er ikke noe definert perimeter. Så vi må tenke litt annerledes når det kommer til sikkerhet. Så det er ikke veldig vanskelig egentlig å få en oversikt over sårbarheter, eksponeringer og generelt trafikkmønster. Så når man ønsker å deployere applikasjoner i et så høyt tempo som er nødvendig med den måten vi konsumerer applikasjoner på, så er vi nødt til å tenke annerledes. Vi må bygge sikkerhetsløsninger på samme måte som vi har gjort med cloud native applikasjoner. Så vi må inn, og så må vi designe det på samme måte. Så vi må se hvordan er det containerne, hvilke prosesser er det containerne spawner opp, hvordan kommuniserer de, og gjør de ting som vi har sagt de skal gjøre. Og da er vi nødt til å samarbeide med utviklerne. For det som ofte har skjedd, det er at vi, sikkerhetsteamene, blir ofte sett på som sikre. Og ideen, alt skal skje så fort. For å følge med i utviklingen, så kan man ikke være en sinker. Da må man kjøre på og gjøre ting så smidig og raskt som mulig. Med god kvalitet. Og nå er det ekstremt enkelt å omgå sikkerhetsløsninger hvis det ikke er gjort riktig. Så man kan da spinne opp nye infrastruktur både i samme sky, men også i andre skyer. Da mister man visibiliteten i mye større grad. Så det man må gjøre er å involvere utviklerne, gjøre det slik at de får et visst eierskap til sikkerhetsløsningen, og gjerne integrere sikkerhetsløsningene inn i deres utviklerverktøy, slik at de ikke trenger å fokusere på andre og nye verktøy. Så det må en endring til for at vi skal kunne enforce applikasjonssikkerhet. Og det er dette vi snakker om når vi snakker om shift left, det er et buzzword som har kommet de siste årene, hvor det faktisk er, det er noe i da. At man ønsker å skifte fokus på sikkerhet fra det siste man gjør til det første, og så følge hele veien. Sant? Sikkerhet det er alltid et lag. Det er alltid flere lag for å ha en god sikkerhet. Her er en typisk utviklingsprosess, da, hvor man har kodespråk, man har kodeeditorer eller IDEer. Så man kan jo starte med å integrere løsningene inn i det, for å kunne sjekke etter sårbarheter, for å kunne sjekke etter miskonfigurasjoner og så videre. Det samme gjelder med CI/CD-pipeline, som ofte består av, du har en repository, og så har du verktøy som man enkelt kan pakketere og deployere og teste applikasjoner. Alt skal jo skje med infrastruktur som kode nå. Så alt man på en måte spinner opp, det er som kode. Da må man også kunne skanne koden for å se om man har miskonfigurasjoner eller sårbarheter. Og ikke minst runtime. Er vi sikre på at, hvis containerne for eksempel begynner å oppføre seg på en helt annen måte enn det man har sagt eller man har i utgangspunktet tenkt, så må man kunne se det og bli varslet. Hvis man gjør dette på en skikkelig måte, så har man redusert sjansen betydelig for å få sårbarheter og bugs, mener jeg. Det var egentlig det jeg hadde å si i begynnelsen her. Dima?
Yeah.
Roy?
Yeah. Hi guys, I'm going to do it in English. It's easier for me and you will probably understand me better in English than in Norwegian. So I am going to share my screen now. Just Benjamin, please confirm that you do see my screen. All good?
Yes, I can see your screen.
Yeah. Okay, so yes, as Benjamin was talking about different timelines and application lifecycle. So and that's code build, deploy, run, because they're a bit more, but more tactical one. But like the big one are those ones that you can see on the screen at the moment. And now what I'm going to talk about is a little bit about the risks that we can see in different stages here. And afterwards, I'm going to show you how those risks can lead to the, let's say, to disaster, and how that those risks can lead to basically not only the applications, but probably even the whole cloud account owned by the malicious actors. So let's start from the left side here, and what we are seeing here is build phase. There are multiple of the risks. First of them is the insecure infrastructure as a code. So infrastructure is deployed in the cloud using the infrastructure as a code template, such as Terraform or CloudFormation or Bicep. And if the developer creates those with the severe misconfiguration inside, that can open the infrastructure to exploitation. Another thing is the vulnerable application. On top of the infrastructure that we deployed, let's say on the previous stage, we deployed the application. The applications are today more like assembled than created from the scratch. And what I mean here is that the developer is writing probably 10% of the code. The rest of the code is the dependencies or libraries. And those libraries are usually the open source. And if they are open source, means that they have known vulnerabilities. And that means that they can also be exploited. The other thing here is the insecure configuration of the version control systems, such as GitHub or GitLab, or Azure repos, where it's just public access is granted there, and obviously the code can be visible for anyone else. And especially if some exposed secrets are sitting in that public repository, that almost immediately means that your infrastructure is going to be owned by some bad guys. On the next phase, on the deployment phase, there are other risks, such as the malicious images. In many cases, developers are just calling to GitHub, to the Docker hub and getting the images out of there. And those images can be definitely malicious. They can include some malware, they can include some backdoors. That's also known as the image poisoning. And the last phase is when we are running application. And when we are running application, actually we are consuming the consequences of not addressing the risks on the first two phases, which means that if we would have done something on the first two phases, on the running phase, we probably wouldn't even have those challenges. But let's look at them. So what we have here is challenges or risks such as malicious web attacks, which is the capability of exploiting web application. While exploiting web application, there are some other risks that can be utilized afterwards to go further, and that is the overlay permissive access. In many cases, we see out there in the cloud that many resources configure and users are configured with the overlay permissive access, meaning they have access that they don't need to have. So not a zero trust permissions. And then those permissions that those resources have can be used to move laterally and even get some privileges to get the admin account in the public cloud provider. And as the result of that, the data exfiltration, which is the main goal of the bad guys, or probably starting to run some coin miners in the public cloud infrastructure. Now, what I'm going to do, I'm going to demonstrate how that things may happen. And that's a very much realistic example of what can happen and actually what happens all the time, so that you can realize that and see it with your own eyes as well. So I'm going to exploit cloud native application, and I'm going to get even further. I'm going to get the admin account created in AWS infrastructure, and I'm going to get the access to the whole resource set of that specific cloud account. And please do not repeat it at home, because that can be quite dangerous exercise. So what I'm going to do, and starting from the first stage, I'm going to deploy the infrastructure. So from my laptop, I am going to deploy the infrastructure using the Terraform template. That will deploy the EC2 instance, security group that covers that EC2 instance. And for those who don't know, EC2 instance is the virtual machine on the AWS cloud. That virtual machine is going to have some misconfigured privileges. Basically, that virtual machine will have the privileges to do whatever inside the AWS account. That may sound a little bit weird, but that's what is happening all the time, because developers need to have the virtual machine to execute certain actions against other services. And then the easiest way to do it is just to allow permission equals to asterisk, basically everything. Oh, we will test it now with these permissions, and then later on we will change it. But that change never comes. I will also deploy the container registry. ECR is AWS Container Registry, and S3 bucket. So that's what's going to be done with the usage of Terraform template. So let me just start doing that. So now I am showing on the screen my VS Code. So basically my IDE where I have my Terraform templates. You can see here them on the left side of the screen. And this main Terraform template is actually deploys the virtual machine. It's a Ubuntu Linux virtual machine. And also I have the IAM permissions created for that virtual machine, and then I have the container registry created. So what I'm going to do now, I am actually going to start this deployment. And what you see is actually exactly what developers are doing, not necessarily doing it from local laptop. Probably it will be the part of CI/CD pipeline execution, but just for understanding how that things are done, I'm doing it here from my local laptop. So at the moment, a Terraform template is being executed. So let it work. It usually takes, for this infrastructure, maybe 1 to 2 minutes. Meanwhile, I'm going back to the slides. I'm letting that to work. And the next thing after the infrastructure will be deployed, I'm going to deploy the application on top of that infrastructure. Application will be deployed using the CI/CD pipeline, using the GitHub action, which will build the image, which contains the CVE 2022-22965 vulnerability. That vulnerability is pretty severe one. It has the score of 9.8. And it's the it's a vulnerability in the Spring Core, which allows the remote code execution. So after the image will be built, that image will be then pushed into the container registry, AWS Container Registry, which is called ECR, and then that container image will be deployed as the container running in this virtual machine, running in this EC2 instance. So that is the next step, the deployment of the application. Again, it's a pretty usual situation. After the deploying the infrastructure, the container image is being built, pushed to the registry, and then deployed into that infrastructure. So pretty much very, very real life example. So let me switch back to my IDE and see, yes, it's done. Basically now I have my infrastructure built. I'm coming now into my AWS console, and we can see that there is the EC2 instance running. So virtual machine is running. I'm going also look into the IAM to see how many users currently I have. Currently I have 2 users. One of them called Dima, another of them is called GitHub Pusher. Basically, GitHub Pusher is the user to integrate with the GitHub action. So just remember this, that I have 2 users at the moment here. One of them is Dima, another is GitHub Pusher. And the last thing I'm going to check is my container registry. And indeed, my container registry has been created. I need just to get that information of the name of that container registry, because I will need it in my pipeline execution. Right now, I'm going to my code. I'm going to my GitHub. And in GitHub, I have my application, which is built here. And then if I go to code, there is this Docker file, which is actually building this container required in my case. Simple thing. Now I'm going to build this application. I'm going to run this workflow. The only thing I need to add as the parameter is the container registry, so that my image is going to be pushed to that container registry. Now I will press run workflow. What is happening at the moment is that the build task is started. So my application is going to be built and then pushed into the container registry. It's again takes about 1 to 2 minutes. So I will let it work. And meanwhile, I'm going back to the slides. So that's what is being executed at the moment. My application is going to be deployed in the infrastructure. The next step is actually exploitation. So what I will do after the application will be deployed, I will use the computer in internet, which will exploit this vulnerability, this Spring for Shell vulnerability, and then the malicious actor, after exploiting the container, basically what would happen is that the malicious actor will check, okay, what me, after getting hold of this virtual machine via the container, what I am able to do on that virtual machine. And that's basically done via querying of metadata service of AWS. And then suddenly it will be identified that IAM permissions are whatever for this virtual machine. Realizing that, the malicious actor then will create the new admin account, because IAM equals to asterisk means that this virtual machine is capable to do anything in this AWS account. And then this malicious actor is going to create new admin account and basically log in using that admin account into this AWS account. So basically that bad guy is going to own this whole infrastructure. For security purposes, you see here, there is this S3 bucket, those scripts for actually executing the creation of users, they will be done from the local S3 bucket running privately on that account, so that I'm not actually exposing myself here, but that's what's going to happen. In other case, probably it would be executed from a malicious guy's laptop directly. Okay, let's now come back and see whether pipeline have successfully executed. It looks like that. So the whole pipeline is green, meaning it is executed. Now I am going back to my container registry. And I see that there is this Spring for Shell demo container image is in here, meaning everything went well. And there is one interesting thing actually I want to show you as well. So the AWS has the service to scan the containers. And funny enough, in this specific container image, there is only one critical vulnerability, which is not the one that I'm going to exploit. So there is no, the AWS by default was not able to identify the critical vulnerability which is going to be exploited. So the point here is that in principle, using only the native solutions of the cloud may not be even enough to even identify your risk. So in this case, AWS scanner was not able to identify the vulnerability which I'm going to exploit at the moment. But let's look further. After execution of my Terraform templates, I have the output parameters, which are also giving me the links to my application. Now I'm going to test whether application is really running. Yes, it is running. So this is my application, Apache Tomcat here. You see, I have my application up and running right now, which is great. And let's do the dirty things. At the moment, I'm coming back to my console here. And what I'm going to do, I'm going to execute the script, which is called gain access here, which actually refers to the exploit shell script as well. And that is actual curl command, which is exploiting this web application vulnerability. So it's quite a long line. I decided to script it instead of putting it manually one by one. So basically here, what's going to happen is that this will be executed, this web request will be executed, and it will exploit my application. After exploitation of my application, I am going to install some additional software on top of it. As you can see here, some curl, unzip, less, and also AWS CLI. And AWS CLI then is going to be used to query metadata and, of course, for creating of the IAM user. So everything is scripted. I don't need to put all the commands by myself, just for the sake of simplicity. I'm running this script gain access sh now, and what is started, the exploitation has started, and you see that it tells me that the shell is now accessible. And what I'm going to actually do, I'm going to go to back to the application and see if it is the case. I will run some command, for example, list file system. Okay, oops, something didn't went well. Yeah, that is correct. Just give me 1 second. Some syntax challenge. Yes. And you see, I am able to list the file system here. Here is my system, file system, bin, conf, include, lib, log. I see the file system. So basically what that means is that I am able to execute remote shell commands here on this application. And coming back to my script, it's already executed. And as the output of the script here, I see the following. I see that here is my console address. Here is my randomly generated password, and here is my user that I'm going to use to go to the console. And let me do that. So now I am opening some private window here. I already had that password embedded. So sign in. And here you go. I have been able now to log in to AWS account using this new user whose name is Pwned, and that new user has the full access to the infrastructure. Now this user, as you can see, has the access to my EC2 instance. That user also have the access to the my Azure Container Registry. And here you go, seeing the same container image, seeing the same vulnerabilities here. And what is more important, if I'm going to IAM, I am going to see this. Now I have these 3 users here, including this new user, which is Pwned, and the last activity just now, and the user was created just 2 minutes back. Okay, so this is the result of this exploitation. So to summarize, before I'm doing the summarization, I want to delete this user from my AWS account. So just for the security purpose. But just to summarize the story, what I have done, I have exploited this application. I got the full access to AWS while utilizing overprivileged configuration of my EC2 instance. And now I am able to exfiltrate whatever data I want to exfiltrate, and even more, I can actually create more users, I can create more resources, and I can start mining coins. I can do whatever I want to do in this AWS account. So going further, question, but fine, what we can do in order to make sure that those bad things are not happening. Starting from the code and build phase. First of all, we need to utilize the say strong tool set which can help us of mitigating those risks. Starting from this left side, first thing first, scan all infrastructure as the code templates for misconfiguration and fail the pipeline based on critical and potentially high misconfigurations. There are tools out there in the market which can do it, and those tools are also have capability to do the scans in IDEs, like immediately in the IDE, in the VS Code. When I was creating the infrastructure as a code template, I could have been able to do the scanning and could have identified the misconfigurations specifically related to this IAM settings of my EC2 instance, and I would be able to fix it already when I am doing it, when I'm developing it. I don't need to consume this in the running phase. I would be able to fix it during the IDE. Also, I could do it in the repos. I could have could have done my scanning of my repositories and also identify those misconfiguration in repositories. And of course, in pipelines, I could potentially fail the pipeline with the misconfigured configuration of the IAM for that specific virtual machine. Also, another thing is the scanning of the software dependencies in the same locations, IDs, repos, and the pipelines. So fail the pipeline based on critical vulnerability. Do not ignore those critical vulnerabilities when you are doing the IDE. Do it in IDE. Potentially consider using the next version of the package which does not have the vulnerabilities. Important thing is also to look to the licenses. It's not, of course, the part of the exploitation process, but it's also important from other perspective what you are allowed or not allowed to use in your environment, because there are some licenses that potentially can bring you some legal challenges afterwards. So that's another thing. So scan the licenses, build full software bomb, and then the software bomb also gives you the understanding of the dependencies as well, because it's not necessarily that first line dependency is bringing vulnerability, but it's probably the second line or child of a child dependency which can bring the vulnerability. And the last but not the least, scan files for the embedded secrets. Embedded secrets is the big deal. You all heard about the Uber exploitation last year, and that exploitation actually was very similar to what I was doing today. The end result account was owned, but it was owned utilizing the embedded secrets in the private repos. First, the bad guy got the access to the private repos using the social engineering, but afterwards he was using those secrets that was exposed in the private repository. On the deployment phase, scan the container registries, scan them, and probably not with one tool, with multiple or some trusted tools, the tools that are proven. And even after scanning the container registries, also consider preventing deployment of the containers based on the critical vulnerabilities. You may scan the registries, but then when you are deploying the container in the production, ensure that you have a tool set that can prevent that deployment if you have some critical vulnerabilities or specific vulnerabilities that are in a wild, so that container is not allowed to be deployed. Then enforce trusted images for building your software. It's probably shall be the number one, actually, and it's a really easy win to make sure that whenever you are building your application, it's not taking some images just out from internet. The developers are not taking it just Googling it, but make sure that the images that you are utilizing to build your software are well tested, verified, and put as the trusted images in your system. And you need to have the measures to enforce allowing the images only built from those trusted images as the base layer, only allow them to be deployed in your infrastructure. Run image analysis sandbox. That's as part of CI/CD pipeline. That's also an important element, because what you can do is that you can actually verify if the image, when it's running as the container, if it's doing some strange or weird things. And that will not even be part of your infrastructure. It will be part of CI/CD pipeline runner. The container will be running there, and not in your development or production infrastructure. So first, verify in the CI/CD pipeline runner using sandboxing, verify if the image is trying to connect to some command and control servers, or trying to start mining coins, as an example, or something like that. And the other thing here is enforcement of checks on the Kubernetes deployments and avoid misconfigurations on the Kubernetes deployments files themselves. Use the admission control to allow only deployments that are proper. And then coming to the running phase, on the running phase, check resources for the misconfiguration on real time. So yes, you may have deployed something with the Terraform templates which are properly configured, but then someone could have gone to console, AWS console, and change the config, and you will not know that it was changed. So verify that, make sure. And the best thing is, of course, to have some tool set which will let you know that you have a drift between the configuration that you have in Terraform templates and in the real life running configuration. So check resources continuously. Follow compliance frameworks. That also gives you the understanding how compliant you are and gives you the initial view for the best practices. For running containers, check them on the vulnerabilities continuously as well, because container may be running, it may have passed all the gates before it was deployed, but then after it has been deployed, you may have new vulnerabilities discovered in a while, and then that vulnerabilities could have the significant impact into the environment. So don't forget about checking the images of running containers periodically and constantly. Ensure container immutability with runtime checks. So again, tools that allow you to baseline the container behavior, looking into the processes, networks, file system activities, and enforce that behavior, that immutable container philosophy, so that container is not suddenly starting to run some new processes, like in the case of exploitation that I were doing today. Suddenly containers start to do the apt-get or curl commands, which not the usual thing for the container to do, specifically for the web server, and that was in my case. Use web application firewalling and API security capabilities, not only north-south, but also east-west. Again, that is important because after getting one of the containers, in the infrastructure owned, then this lateral movement using the exploitation of the other containers will be easy. So you need to verify that you are whitelisting the APIs between the containers. They're token APIs, so its API calls is what they're doing. You need to make sure that those APIs are not exploitable. Big thing, verify IAM permission for resources, the running resources. Like in my case, the EC2 instance had very overprivileged access, over permissive access, and that's how I was able to create the additional admin user. So make sure that you know, again, real time, not only in Terraform templates, but also real time what permissions your resources have. There would be resources that would be created in the shadow, for sure, by some guys making the shortcuts. You need to know that. So verify IAM permissions when resource is running as well. Take some advantage of analyzing the flow logs, like VPC flow logs, NSG flow logs, and the audit logs of the cloud to identify anomalous network and user activities. And the last but not the least, enforce data security as well, making sure that the PIIs are not exposed out there. And my last slide is just a sort of type of the products for your better understanding. Currently, there are those cloud-native application protection platforms, Gartner defined, that are available on the market, and they are doing these different things, and they have those names like cloud code security, cloud workload protection, CSPM, cloud security posture management, KEAN, cloud identity entitlement management, and so on. So those are the type of the tools that are there. But of course, there are multiple different tools doing this thing. But if you are after the cloud native application protection security, the best thing is to have the tools that are covering the most of those different areas, and that type of the products or platforms are usually called cloud native application platforms. In general, that is the last line that I have, and I just want to turn over back to the organizers, and maybe Benjamin, you can also check out if there were any questions in a while. Thank you.
Thank you, Dima. No, I can't see any questions here. So, well, that's all for us. Thank you for listening.